And certainly the next one that I can see here is this mirrored flange, okay, sitting on a base. Now, we can certainly proceed to develop these features, but we also have these other face features that if we look at our auxiliary face A and then our auxiliary face B, we can actually utilize the model faces as planes to develop our sketches. Okay, so why don't we take a look at auxiliary face A and B, and let's do those features there before we continue with our flanges. Okay, so I'll call this auxiliary face A and this will be B, and what I want to show you here is for the features that you see here in this face, such as the rounded edge, you can see that it's a radius of 125. We can use the fillets. We can also use, for this counterbore, we can use the whole wizard. You have all the information that you need right here. Then you can see that we can simply create a profile to cut extrude into the auxiliary B face, as well as utilize the auxiliary B face to create a profile that will then be cut into the auxiliary A face. So let's take a look at how we'll proceed. This here will be my auxiliary face A. So to start with, let's take a look at these top corners. Okay, if I pre-select the edges here, what I'll be using then is a feature to create the rounded edge, and that feature will be a fillet. Using the fillet tool, you can see here we'll have a constant radius, there's no variation, and the items to fillet, you can see it's edge 1 and edge 2, and then here's the value. We're going to use 1.25 there. Now, once you bring in that numeric value, you can look into the drawing area to see the preview, right? And you'll notice it says tangent propagation and full preview. That's how come you can see what the result will be in yellow, right? So this is the only time you want to do the fillets, right? When it's a major feature. All the other fillets, like the faces and the corners, that should be last. So here, I got the rounded edge, right? And now I want to continue with the counterbore. So just by selecting the face, okay, notice again with your pet palette, if I use edit sketch, what I'll be doing is editing the sketch that drives this feature, right? That's not what I want to do. Let's cancel the sketch. What I want to do is I want to use this face to draw on a new sketch. So I'm going to use sketch here, and now you can see here's the center, right, of that sketch on that face. Also in the design tree, you'll see off to the left, okay, the name of the new sketch I just created. There's nothing in there right now, but there soon will be. So again, I'd like to keep in mind reference geometry, right? Set up reference geometry first. Now we know that this counterbore is centered and it has a dimension for the setback. And what we could do is using sketch tools, here's center line, off to the side, I'll just draw a vertical line. How do I know it's vertical? Well, you can see as you're moving the line around, right? You can see the tooltip. Now, what I can do there is go to selection mode. So escape, pre-select the center line, then control click the sketch origin, right? Using your relations here, you can create a relationship. Now, let's see. Oh, I didn't snap to the origin there. Let's try this. I'm going to take a look once more to make sure. Yeah, we have our origins there. So I got this line selected. I got that edge selected. And we should have an option here for mid-plane, right? This way we'll be able to align it with that. No matter. Look, here, we'll try this. We'll use a center line, and notice how we can just create an extension line right off the midpoint there, right? If I start just off the face and then create the vertical line like that, now it's aligned with the face and centered, right? No need for additional dimensions or other geometry. The other thing that we could do here is now we could create the horizontal line. Right? There's that. And then escape and go back into selection mode, so I can just select the line. And now let's try this edge right here, right? Let's try this edge. You can see we can create tangency. But what we actually want to do, right, is we want to possibly make it go through the center of this fillet edge, or we could. This is where we could use our smart dimension and basically select this edge and the reference line, and then simply add a dimension such as 2.00, right? And that'll do it too. So this is just helping us establish the reference geometry, which is going to further help us establish our feature geometry. Now that we have those reference lines, now what we could do is we go back to features, and for holes, what I would recommend you do is work with the hole wizard. So this sketch is just for reference geometry. If I close it, okay, I can still see my reference geometry. In order to snap to reference geometry, sometimes you need additional geometry like points, right? If I wanted to, what I could do is go back and edit the sketch, and you'll see here's a point. I could bring that point and bring it right to the center, or use the intersection of those two lines, and that could be another additional reference point there that I can use when adding my features. Now, I'm out of that sketch. I'm in features, and here's the hole wizard. If we take a look at the properties for the counterbore, what you'll be able to see here is we have a hole type, which is counterbore. Okay, we define the type first, then the position. So first we have counterbore. We know that it's ANSI inch. Okay, now here's the other thing. Unless we have a particular hole, a standard hole size, okay, we could make our selections here, or what we could do, let me collapse all of these other options, or what we could do is actually use legacy hole. With legacy hole, this is how we could customize our own holes as we see fit. If I use legacy hole, you'll first determine the type. Here it's just a simple hole, but what I want to do is make a counterbore hole. Now you'll see a little graphic here, and you'll see here's the large 1.575 counterbore diameter, and then you have the hole through diameter, you have the depth, and etc. So all you're doing now is you're using this little graphic to change, right? To change your information. So for example, the hole through diameter there is set to 0.75. So if I just double click here, highlight the value box, and just change it, 0.750, don't worry about the problems that might arise, not yet. If I double click here, let's try a different value box here. Here's the counterbore depth. Okay, that should be 0.375. Then the counterbore diameter there should be 1.250. Now, the depth here, right? The total depth, that is variable, right? Because what we're doing is we're going to look at the end condition, and you could see this is going to go through all. Or is it, right? Do we want to go through all? Probably not, right? We just want to make sure we go through the surface there. So take a look here, up to surface. Now, these are the settings for the hole using the hole wizard, right? So we defined it as a legacy hole, a customized profile, and we've added the dimensions that we want in there. Now we can take a look at positions. It's this with positions where we come over here and we select the face where we want to put it. Now immediately look what happens, right? Is there any way that I could snap to that intersection? Well, I can, only because I put a point there, right? But look at this. When I click on the point, nothing happens, right? If I click off to the side, now you can see that I can place, with the pencil there, my hole. What you want to do first is you want to select the face where you want to place the hole. Then, with the pencil, you're going to indicate the position, right? So I click there, and notice, now it's locked right into position. I can continue inserting the same hole over and over again until I'm done just by clicking OK. Now, also, because remember, we said up to surface, right? We have to specify what surface. The back surface here, the top surface here, or here's the value box, this surface right there. That's how we limit the depth of the cut. If I click OK, you can see there's the profile. On the other side, there's the counterbore. Okay? So that was done with the whole wizard. As we proceed now, let's take a look at the slot. This center slot that goes through, you can see that we're actually going to be working on the opposite side, right? Or auxiliary face B here. And if we take a closer look here, we can see what the dimensions are. Right? We got about 250 depth. And if we look here, we got 0.875 total length of the opening there. Okay? And you can see how it's centered on that face. So, if I select the face, I can get normal to it. Okay? Selecting the face again, I can create another sketch on it. There's the center line, right? Or there's the center reference point, the origin. Do I need to make more construction lines? Not necessarily, right? But if I want to, I can. All I need to do here is establish a rectangular profile, right? Real simple rectangular profile. But now I got to add the precision and the accuracy to it, right? So this is where my smart dimensions come into play. I know that overall it should be 0.875, right? But I also know that it should be centered to the origin. So if I select one edge, snap to the origin, set this dimension as 0.875, divide it by 2, right? That'll center it on that face. Then lastly, I have the thickness or the height of that rectangular surface, which is 0.250, right? So there it is. And you can see right now, if I orbit around, now we need to consider again what sort of feature we're going to use and what's the end condition going to be. So that's the sketch entities I want to use. Switch over to features. This time I'm going to use Extrude Cut. Now, you can see here, as a blind Extrude Cut, right? I can certainly make it at least 4 inches. It'll go through the whole surface there to get the result I want. Or I could even do this. I could say up to surface and select the rounded edge, right, as the surface. And look what happens there. Or if I go up to vertex, I can use a vertex on the sketch or on the part itself, right? Or in this case, might not even make a difference if I go through all. So take a look at the different end condition options, and just for experimentation, take a look at what the results are. You might be able to get the same results with different features. Now look at that. Okay, so that pretty much completes auxiliary face A, and now we can take a look at creating the slot in auxiliary face B. And for that, we can take a look at the sketch up here. Now, we can see a little bit of symmetry, and we can certainly use our sketch tools to create this in a very quick and efficient way. Let's take a look at that. Okay, So what we want to do here is we want to create a slot that runs down this face. So the best thing to do here is to select, right? Select our face and insert a sketch on it. Okay? Again, if I select the face, I can go normal to it using my heads-up display, right? Now look at this. If I want to rotate the view, I can use the Shift, Control, and Alt keys together with the arrow keys. If I do Alt and do left arrow key or right arrow key, you can see how I'm rotating it with increments, okay? And this way you can rotate your view, okay, without rotating the model. So in this view, I can more easily lay out the sketch, right? Now, here's another thing. Notice how I already have sketch geometry here, right? I want to borrow this sketch geometry. I want to be able to use this sketch geometry in my own sketch, right? Well, one thing I could do is I could actually use convert entities. So I select this sketch and I use convert entities here. And what it does is it creates a copy of that line and projects it into my new sketch. But it creates a regular line, and I could just change it back to construction, right? Now I can use this line for referencing. All right. Now the reason why I do that is because what I want to do is I want to use dynamic mirror. Okay. Once again, select the face, and I'm going to get normal to it. Using Alt, you can see how I can just use the arrow keys and rotate myself around. Now in this view, you can clearly see how I can now establish my profile. What I'll do is I'll just use lines, starting coincident with this edge, just making an angle there and coming across here. Okay? So I have basically an open line or an open profile, and it's symmetrical. The other thing I can do here is you can see using my dimensions, okay, I can establish a angle of 30 degrees. There it is. And then the depth, which is going to be 0.250. And then a distance from this edge to this edge, which is going to be 0.437. And there's our profile. Now, you'll notice that we're starting at one end of the face, right? And if I switch over to features now, and I'll use Extrude Cut, now you'll see here a slightly different cut extrude operation, okay? What you'll notice here is you'll have a flip cut, which will determine what side of the profile the model will be cut. So you can see here, using the dynamic arrow, if I click on it, you can see the side that I don't want cut is going to be cut. Or if I click on it here, I can flip it again. All right? And you can see you could do that with your direction arrow here. When I click OK now, you'll see the slot is created. All right, let's finish up with auxiliary face B here. We've got a couple holes that we want to draw in. So what we'll do is we'll select the face, create a new sketch, and then make sure the face is selected and go normal, right? Here again, you can see I have the sketch origin. I can create reference geometry if I want to. Tracking from the origin, some distance away from the face, creating a vertical construction line there to establish the symmetry. And then I could use sketch circles coincident with that line, and then create another sketch circle. Now what I'll do here is I'll use relations. So for example, if I select first circle and then control click the second circle, we'll create an equal relation, right? So as I change the dimension of one, the other one will change too. And to constrain it, I'll use smart dimension on one, and you can see here this will be a radius of 0.250. Okay, you see that's a diameter, but if I right click over it, display as a radius, double click, 0.250, there we go. And then the distance, right, from this edge to the center here will be 1.125. And then again, the distance between this center to this second center is also 1.125. Okay, now, so you can see here, we're starting on this face. Now remember, we're going to have flanges here, so we don't want to do through all. Okay, what we want to do is use the feature, Cut-Extrude, and what we want to do here for direction is we want to use up to surface. When you select that option, then just touch the top face here so that our Cut-Extrude only goes to that surface. Click OK, and now that model face is complete. So the next step that we want to take a look at is setting up for the flanges.